Good morning, guys. Welcome to today's tutorial. I had a really good question this morning from one of my students, and that was about how do I know whether when I'm integrating the answer will be a log. So I thought it's a really good opportunity to attack this style of question because I didn't have anything on that particularly. So I thought we'll look at integration in fractions. I put logs in brackets because most of the time the answers will be logs, but not all the time. So the first, I said basically there were two main aspects that I know when it's going to be a log. The first one is it is a fraction. Okay, that's the very first thing. So if we are integrating a fraction, then there is a really good chance that it will be a log. Now, I have to say it's a good chance, or most likely it's a log, but not certainly. Okay, so there are going to be situations where, and you will see that today, that it might not be a log, but certainly that's the first thing I would look for. So is it a log? Yes. So is it a fraction? Yes. Therefore, the second test I would look at would be when integrating normally, and this is, you have to remember your rules for this. You're integrating normally, and that I'm going to put there, you are adding 1 to the index, and then of course you then divide by that number as well. But if you add 1 to it by integrating normally, and the power or the index is 0, then it is definitely a log. Okay, and that's a really good indicator. So first of all, is it a fraction? Yes. Then if I integrate normally, does it equal 0 for the power? Yes. Then certainly it's a log. So what do I mean by that? Well, let's say, for example, that I've got this question here where we're integrating 1 over x. So certainly the first one checks in that it is a fraction. The second one, if I integrate it normally, well, let's put it to x to the negative 1, because that's going to be the same thing. Now, if I do this normally, and I add 1 to this number here, then we get x to the power of 0. That doesn't work. And particularly then, I would then divide by the 0, which we know we can't do. So that's not going to allow us to do it correctly. Okay, so that tells me certainly that it's going to be a log. So how do I integrate the log? Well, hopefully you remember your differentiation. If I said, for example, I'm going to have y equals 5x over, scrap that, y equals log e 5x, because remember when we're doing a differentiation and our integration, we always do it with log e or ln. If I had to differentiate this, that means dy dx. Hopefully you remember the rule was f dash x over f of x. Okay, in this case it would be 5 over 5x. So the good thing is that when you have got your fraction here, the function, the original function, okay, is on the bottom part of our fraction, is our denominator. So in this case, the x is actually our function. So we can write here log e x. Now, most of the time, that will be correct, and that will be your answer, but I will always like to test it because you will see that it won't always happen. For example, if I went ahead and differentiated that, do my f dash x over f of x, we would have, we'll integrate x, we get 1 over the function. Is that correct? Yes, it is. Therefore, that is my answer, and I've got it. There will be some cases where when you test it, it won't be exactly what you wanted, and you have to modify it slightly. So we'll have a look at that. Okay, so we're going to look at a range of questions now. Again, you might want to pause it and have a crack on your own. That's up to you. You might want to follow it through. The first one I'm going to look at is 1 over x squared dx. So now remember I said to you that these won't always be logs, but most of these will be. So first of all, is this a fraction? Yes, it is a fraction. That's our first parameter met. Second of all, if I differentiate this normally, would it equal 0? Well, let's do this. Integrate x to negative 2 dx. Well, if I add 1 to this, what do I get? I get x to the power of negative 1 over 1. Well, hold on. Look at this. That worked. There wasn't a 0 there. Therefore, guess what? Your actual answer is going to be just 1 on x. So that is a particular case where it wasn't a log. Okay, but that again, we went through the parameters. Is it a fraction? Yes. When I do it normally, is the power equaling to 0? In this case, no. And just before I move on, I nearly made that little mistake there, didn't I? That was -1, that's -1. Okay, so I need to put my -1 there. Okay, yeah, so that part, it wasn't going to be a log because when I did that +1, it wasn't 0. So there you go. The next one we're going to look at, so you can pause this if you wish. We're going to do the integral of x over x plus 3 dx. Alright, let's have a look at this question now. Now, first of all, number 1, is it a fraction? Yes, it is. So there's a good chance this could be a log. Number 2, if I integrate this normally, would it equal 0? Now, this is a slight one. I mean, look, for the most part, you'll get used to this and say, yes, this is a log by looking at it straight away. Okay? But another thing here, actually, should this be x squared? Sorry, my bad. It should be x squared. If I do this the normal way, x squared plus 3 to the -1, and we've got the x at the front. Now, to start off with, we don't really know how to integrate a product rule anyway, so that should tell you straight away that it is going to be a log because there's no other way for 2-unit maths for us to do that. But also, the thing is, if I put my +1 here, that becomes 0, okay, and then you can see that's not going to work out. So that didn't work, therefore, this is a log question. But as I said, you'll probably pick it up really quickly. For example, when I'm doing this question myself, I actually look for the rule f dash x over f of x. That means if I integrate this bottom part of the function, does it make the top part? Now in this case, it gets pretty close, but it's not exact, which is a good thing for us to go through. So if I integrate this, I know it's not a log, so I know it's a log, so I'm going to start off by doing log e of the function on the bottom, x squared plus 3. Put that in brackets because it's two functions. And I'm going to put my plus c there. I didn't do that last time, so just be careful. Okay, now I said to you that sometimes be a little bit careful because the answer will not be this straight away. Sometimes. It will most of the time, we saw the previous question, but not all the time. Now, so I said to you before that I like to test it. I like to actually go back and put it into our differentiation rule. So if I differentiated this and make it 2x over x squared plus 3. So that's if I differentiated this function here. There's an issue though. If you look back to my original question over here, those two things, unfortunately, they are not the same. When I integrated, or when I differentiated this function, I got 2x on top. However, my question just had x. So this integration here has got an extra multiple of 2 on top. So how can I get rid of that x times 2, that times 2? Well, what's the opposite of times 2? It is divided by 2. So if I do put a half out the front and make it a half log e of x squared plus 3 plus c, that is now what my function is going to be. So can you see what I did there? I really hope you can, because it is a bit difficult. That when I notice that it was a log and I put the function straight in, I always test it just to make sure that it creates the question that I wanted. If it doesn't, you might have to divide it by 2, like this case. You might have to times it by 2 if you are in that sort of inclined that kind of question. Anyway, let's have a look at number 3. Number 3, we'll do the integral of e cubed 1. And 5 on x. So this one will be a definite integral this time. So you won't have to put the plus c, but you will need to sub in some numbers. So first of all, we need to integrate 5 on x. So let's go through our test. Number 1, is it a fraction? Yes. Number 2, can I integrate it normally? Well, this would be 5 to the x negative 1. And if I plus 1 to that, that makes 0. Therefore, I cannot do it normally. Therefore, this is going to be a log. Hopefully, you can start seeing the testing that I'm doing. So, when I do this, I'm going to put here, we're going to put log e x. I have my e to the power of 3 and my 1 there for my values. Now, remember I said last time we must test this just to make sure it makes this 5 on x. So if I differentiated it, dy dx, okay, and I did this for log ex, well, differentiate x, we get 1, and then my function at the bottom, we get 1 on x, but we have a problem. So, this answer, unfortunately, generates 1 over x. We want 5 over x. So what can we do? Well, instead of, last time we had to divide by the number 2 because we need to get rid of this. But now we've got 1, but we want 5. So what do? We're going to multiply it by 5. You can put the 5 on the outside. You can put the 5 on the inside. It doesn't really matter. I generally put the numbers on the outside here just so it makes the log inside a little bit easier to do when we're substituting into it. So now we've got 5 outside of, we've got our log e of e to the power of 3 minus log e 1. Now there are certain times where I look at this and go, hold on, something's going on here. I've got log EE. We might remember that log EE is 1. And actually, if I've got a power of 3, I can put the 3 down there instead. So it makes 3 times 1. But guess what? You have a calculator. So if you have a feeling that it might be doing something tricky, just put in your calculator and it'll come up with the answer of 3 anyway. So we've got 5 outside of, we've got 3 minus log E1. And again, if you're not sure about log E1 and you think it could be something special, then you can put it in your calculator, but hopefully you might remember that log E1 has to be 0 in this particular case, and then we get 5 times 3, which is 15, and we can just put 15. There's no area, so we don't have to put units squared there at this time. So that's quite a challenging question, guys, but you can see it's another log question. I'm going to be putting a few more, so I know it's getting to 12 minutes. We'll probably go up to about 20 minutes, so feel free to keep on going or stop as you wish. All right, the next one, so number 4 we're up to now. We're going to do the integral of sine x on 2 dx. Okay, so first of all, well, this is a little bit more challenging, this one, because look at this x on 2. Now, hopefully you might realize that that is exactly the same as doing sine a half x dx. They're the same thing. So you might recognize it, you might not, but you might need to write it in that format. It's up to you. First of all, number 1, is it a fraction? Yes, it is. Number 2, well, actually, it's not really a fraction, I guess, because it's, well, we'll still put it as a fraction. Number 2, could I differentiate normally? Let's see what happens, or integrate normally. Well, if I plus 1 here, this is already 1, isn't it? If I plus 1 to there, it makes 2. Yes, I can. Guess what? We can do this normally. So, yes, we can. Therefore, it's just integrate normally. So, sine. We know when we do this, sine will go to cos, but it actually goes to negative cos 1 on 2x. And then I need to put it all over 2. And put my plus c. Now, actually, I need to put it on 1 on 2. Sorry, my bad. Okay, so hopefully you followed that. So again, I did my negative cos because it's integration of sine, half x because that's my function. Then I need to divide it by the differentiation of this function, which is a half. Now, my last step is negative over a half, or negative 1, I guess, divided by half is negative 2. Cos a half x plus c should be my function. Still pretty challenging, but you know what I like to do? I like to often just double check by, like when we do the logs, go ahead and differentiate just to make sure on those more challenging ones that's correct. If I was asked to differentiate this, well, I know cos goes to negative sine, so I'd have negative negative, which makes it positive, sine, sorry. We've got our half x here. Remember, half times 2 is 1. Okay. And then I need to take 1 away. Oh, look at that. See what we forgot? We forgot to put the 2 there. How good is that? How good is checking your answers to make sure that you don't make a mistake. Because I do that, I subtract the 1, I get my answer, which is exactly what we started with. So you can see how easy it is to forget some of your numbers when you're doing your process, but if you go through those that motion of checking each time, you can pick up those little silly mistakes, which that nearly quite was. Okay, the next one. So that was number 4. Number 5. Okay, so we'll do integral of 1 over x squared plus 1 over x dx. Let's see if you can do this one on your own. Okay, so number 1, is it a fraction? Yes. Number 2, can I do it normally? Well, possibly, possibly not. Let's have a look. This is the integral of x to the negative 2, and this is the integral of x to the negative 1 dx. If I add 1 to this one, yes, that one works. If I add 1 to this one, no, it does not. So this is a bit of a combination question, because I can integrate this function here. If I integrate this, we get x to the negative 1 over negative 1. If I integrate this one, this has to be a log. So we've got here log ex. Now if I check this function here, log ex, well, that gives me 1 on x. Yes, that's correct. So that's correct. So let's just tighten things up a little bit. I'm going to put negative 1 over x plus log e of x, and therefore we have our answer. I've left a little room so I can chuck in my plus c. Okay, so that one was a bit of a combination question where the first fraction we could integrate normally, the second one it was in fact a log. Often though, when 1 on x, you'll recognize that's a log straight away, hopefully in time. Okay, the next question, number 6 now. We're getting through there, not too many more. We've got the integral of 2 over x plus 3 dx. So let's go through our process. Number 1, is it a fraction? Yes, it is. Number 2, can I do it normally? Well, this would be 2x plus 3 to the negative 1. Plus 1 makes 0. No, therefore it is a log. Okay, so you can see our process goes pretty quick, which means this should be basically our f dash x over f of x if we go back and integrate it. So if we do this, it should have given us log e of x plus 3 plus c. That should be my answer. Have we tested it? No, we have not. So let's test this. If I integrate x plus 3, we get 1. So differentiate x plus 3, we get 1 on x plus 3. Because it's a log. Unfortunately, this one was a 2, so I need an extra 2. So let's put an extra 2 at the front, and therefore we got our answer. Okay, it's as easy as that. Hopefully you're really starting to get the hang of it. Number 7, we're going to do the integral this time of dx over x plus 4. So I'm trying to just present the question slightly different, just so that you can understand how they might look in an examination. These are all HSC questions, by the way. You may or may not realize that when you have a dx on the top there, that actually means 1 over x plus 4 dx. We always have the dx there, okay, with respect to x, but sometimes they might times them together if they're being a little bit of a pain. Okay, that's all it means. We can rewrite that way and go from there. Number 1, is it a fraction? Yes, it is. Number 2, can I do it normally? Well, 1 outside of x plus 4 to negative 1 plus the 1 makes 0. No, I can't. Therefore, this is a log. So we've got that pretty quick again. So if I now integrate this is my f of x. We get our log e, x plus 4. I've got 2 terms, so I'm going to put it in brackets, and then I'm going to put my plus c because it's an indefinite integral. We better quickly check it just to make sure this is all good. If I differentiate x, we get 1 over x plus 4. That's what I had. Therefore, that is in fact my answer. Okay, so you won't have to always add things to it. Often, actually, you won't have to. Okay, number 8. This is going to be our last one, so we might put a more challenging one in here for you. Let's do 3x over x squared plus 5. You might want to pause this one and have a good crack at it. It is difficult, I will tell you that, but let's see how you go. Okay, welcome back. Hopefully number 1, you said it is a fraction. Therefore, it might be a log. Number 2, if I integrate this normally, we get 3x x squared plus 5 to the negative 1. Plus 1 makes 0. That's not going to work out, therefore it's a log. But you may have already recognized that there's a function at the front anyway. We haven't done product rule as I mentioned before, therefore it is in fact a log. So my first step, and this would definitely generate 1 mark, if you put log e or ln, I'm going to use ln this time, x squared plus 5 plus c. That would give you 1 mark straight away. Can I please tell you, if you think it's going to be a log, you're not going to put anything down, just put that down there. Because if it's 2 marks, you're definitely going to secure 1 mark. Now this one, as I said, is more challenging. So let's see why. Well, I haven't tested it, so that's my first thing. Let's test it. If I differentiate x squared, we get 2x over x squared plus 5. So I don't have 3. So I need to do something to it. But what can I times 2 by to make 3? Well, you might say, well, can I times it by 1.5? Because 2 times 1.5 is that. And actually, you know what? That can be perfect. You can put 1.5 there and it works. You could put 3 over 2 there. And that also works. Because 3 over 2 is 1.5. That's the better way of writing it. How would you do it if you weren't sure about what to times it by? If it's even a weird number, it might be a 7 on top. And that's where it can be difficult. So what I would suggest that if you look at this test when you integrate it, so differentiate and you tested it, and you got 2x on the top, what I often do, I always divide by that number, because 2 divided by 2 is 1, and then whatever number I need, we put on top. So if it was a 7 on top, I will divide it by 2 just to make it normal, and then times it by 7. So it'd be 7 over 2. If it was a 5 over 2, etc. They are certainly more challenging, but I'll leave it up to you to have a go at some of those questions. Okay, look, I hope you've understood this. Again, I guess the recap would be going through each time that stuff there. So if I scroll back down to our first page, number 1, if it is a fraction, there's a good chance that it's a log. Number 2, if you integrate it normally and it equals a 0 for our indice, then it has to be a log, so we need to work it out that way. Otherwise, we should be able to do it normally, okay? But you might need to modify it if it is a log, to always check your answer. Look, I hope this made a bit of sense. I know it's a tricky sort of stage. It might still be a bit muddy in your mind, so I want you to go ahead and do some questions from either the books or the past papers. Any problems, let me know, and I hope it made some sort of sense to you. Have a great day.